Okay, so this is continuing in section 10.2, where we are starting by rewriting quadratic expressions by completing the square, and then we're going to use that skill in order to solve quadratic equations. On Friday, you guys were completing the square for expressions that had a leading coefficient of 1. I made another video for that. And then now we're moving on to where we're going to complete the square for quadratic expressions that have a leading coefficient that's not 1. Okay, so for example, this quadratic expression has a leading coefficient of 2. And we're going to need to factor that 2 out first before we can complete the square. So remember, when you're factoring out a common factor, you're essentially dividing each of these factors by 2, like when we factor the 2 out. Because think about it, if we were to distribute that 2 back in, we would just have our original quadratic expression. So now this 2 is just going to kind of hang out front until the end. So this is really just an extra like 2 steps from what we were doing on Friday. And I'm going to put a space between the second term and the constant because I'm going to need to add and subtract the same value. So remember, we look to the coefficient of the second term, and we're going to add that coefficient divided by 2 squared and also subtract it. Okay, so let's rewrite this just so we can see it better. So plus 4x, 4 divided by 2 is 2, 2 squared is 4. So we're going to actually add and subtract 4. And then now, I'm going to, by the associative property of addition, group those 3 terms. And these 3 terms are now a perfect square trinomial. That's what we mean by completing the square. We figured out what we had to add and subtract in order to create this perfect square trinomial, which will factor 2x plus 2 squared. Okay, if we want to think about getting a common denominator here, right, we could rewrite this 4 minus 4 as minus 8 halves. So negative 8 halves minus 7 halves will be minus 15 halves. And then our last step is going to be to distribute the 2 back in. So distribute the 2 here so that we have 2 times the quantity x plus 2 squared. And then this works out nicely when we distribute the 2 to negative 15 halves. We'll just have minus 15. So we've just rewritten this quadratic expression in this new form. Try a different color. Okay, so we need to factor that 5 out first. I'm going to leave space right away. So now I'm going to add 3 over 2 squared and also subtract it. So that's x squared plus 3x plus 9/4 minus 9/4 minus 1. Okay, that's our perfect square trinomial in the green parentheses. So that will factor to be x plus 3 halves squared. Remember, I look to what that coefficient is and divide it by 2 to figure out what this constant will be. And Negative 9/4, I can think of minus 1. I can also rewrite the 1 as minus 4/4. So that will be minus 13/4. And then now when we distribute the 5 in, we'll have 5 times the quantity, x plus 3/2 squared, minus, I think that's 65/4. 13 times 5, 65. Yeah. And we're done. Okay, so there's your U-try. I'm going to leave this. I'm not going to show you how to solve a quadratic equation, the general form, by completing the square. I will show you, we'll do the same process, but go a little bit further in trying to, actually, we'll be deriving the quadratic formula next class. So I'm not going to do this slide for now. We'll come back. Okay. So we want to solve this quadratic equation by completing the square. Notice this is an equation because we have this equals to 0. The left-hand side is equal to the right-hand side. So now that we're solving an equation, we're actually trying to solve for a value or values of x. That if we substitute those values in for x, it would make the left-hand side equal to the right-hand side. So we're actually solving for the values of x right now that would make the left-hand side equal to 0 to match the right-hand side. And we're going to do this using complete the square method. So on the left-hand side, I'm going to complete the square. Same process, I just have this equals 0 hanging out there. So I go, okay, well 14 divided by 2 squared will be 49, so I'm going to add 49 and subtract 49. Now I can put parentheses around those 3 terms by the associative property of addition. This will factor to x plus 7 squared. And then negative 49 plus 46 will be minus 3 equals to 0. I've completed the square. The thing about complete the square method is after you've completed the square, it just switches to be solving by square root method. This should be very familiar to you guys. This is just solving by square root method. So we need to get the x plus 7 squared by itself on the left-hand side of the equation. So we're going to add 3 to each side. Take the square root of each side of the equation. So we'll have plus or minus root 3 on the right-hand side. And subtract 7 from each side of the equation. So when I separate my solutions here, I'll have x equals to negative 7 plus root 3, or x equals to negative 7 minus root 3. Okay, so let's complete the square on the left side. Negative 10 divided by 2 is negative 5, and negative 5 squared will be 25, so we're going to add and subtract 25. Our perfect square trinomial factors to x minus 5 squared. We have the minus 24 out here. And now just thinking square root method. Okay, x minus 5 squared equals to 24. Take the square root of each side of the equation, so we'll have plus or minus root 24. Now, 24 does have perfect square factors, or it has a perfect square factor of 4. So I can rewrite root 24 as 2 root 6. And then adding 5 to each side of the equation, we'll have x equals to 5 plus 2 root 6. or x equals to 5 minus 2 root 6. Okay, I'll do these retries just to give you a couple more examples. Okay, 6 divided by 2 is 3. 3 squared is 9, so plus 9 minus 9. That factors to x plus 3 squared minus 11 equals to 0. Add 11 to each side of the equation. Take the square root of each side, so we'll have plus or minus root 11 on the right-hand side. So x equals to negative 3 plus or minus root 11. Oops. Okay. Okay, notice this equation has a leading coefficient that is not 1. So we need to factor that 2 out. And complete the square inside the brackets. So negative 2 divided by 2 is negative 1. Negative 1 squared is just 1. So I'm going to add 1 and subtract 1. That factors to be x minus 1 squared. And we have the minus 6 in there. So I'm going to distribute the 2 back in before I switch to square root method. Now we can add 12 to each side of the equation and divide by 2 because we want to get x minus 1 squared by itself on the left side of the equation. So we get x equals to 1 plus or minus root 6. Okay, this is I definitely do not think that solving quadratics by completing the square is the most efficient method, but it is a method that will allow you to find all of the real solutions to a quadratic equation. In next class, we'll derive the quadratic formula, which is another way in order for you to find the real solutions to a quadratic equation.